In this video, let's go ahead and practice multiplying and dividing fractions as well as some monomial expressions together. So for questions 1 through 4, let's go ahead and find the product, which is going to be the answer to a multiplication problem. So let's see. For number 1, we have 8 times the 7/12. Now keep in mind that when we are multiplying fractions, we like having a numerator and a denominator each time. So this whole number of 8, let's go ahead and rewrite the 8 as 8 over 1, right? You can really write it as a fraction in many different ways, but 8 over 1 is very straightforward to do. And we're going to multiply this by 7 over 12. Now, when multiplying fractions, you can simplify at the end or you can simplify during as well. So what I'm going to do here is I'm going to write this as one fraction and then see if we have any common factors somewhere on top and somewhere on bottom. I'm not going to write their prime factorizations, but I am going to look for some common factors that we could divide top and bottom by. So if you look at 8 and 12, I think we can divide those both by 4, right? So 8 divided by 4 is going to be 2, and then 12 divided by 4 is going to be 3. All right, so it's kind of like simplifying without actually writing out all the factors specifically. Now 2 times 7 is going to be 14 on top, and then this 1 times 3 on bottom is going to be 3. All right, now it says to write the answer as either a proper fraction, mixed number, or whole number. Because we have an improper fraction here as a mixed number, we're going to say 14 divided by 3. 3 fits into 14 4 times. 4 times 3 is 12, so there's 2 away from 14, so it's going to be 4 2/3. So for our product, we're going to say it's going to be 4 2/3. All right, for number 2, looks like we have a mixed number multiplied by a proper fraction here. So let's go ahead and see. Let's turn the mixed number into an improper fraction first. So 4 times 6 is going to be 24 plus the 1 on top is going to be 25. So we're really looking at 25 over 6 here, multiplied by 3 over 10. All right, written as one fraction here, we can say this is going to be the product of 25 and 3 over the product here of 6 and 10. And let's see, we could write their prime factorizations, but let's just cancel out with some common factors here. We can divide 25 and 10 both by 5. If we do so, we're going to get 5 and 2. And then if we look at this 3 and 6 here, those can both divide by 3, right? So divide 3 and 3. So 3 divided by 3 is 1. 6 divided by 3 is going to be 2. At this point, I think everything is relatively prime. So 5 times 1 is 5 on top. And 2 times 2 is going to be 4 on bottom. This is the same thing as 1 and 1/4 as a mixed number. So that's going to be our answer here. All right, for number 3, we have a mixed number by a mixed number. So this 8 3/4, let's go ahead and turn that into an improper fraction first. So 8 times 4 is going to be 32, plus a 3 is going to be 35. So we're looking at 35 over 4 here, multiplied by, and let's turn this 5 1/5 into an improper fraction as well. 5 times 5 is 25 plus 1 is going to be 26. So we're looking at 26 over 5. All right, so as one fraction here, it's going to be 35 times 26 over this 4 times 5. And let's see if we have any common factors here. Well, yeah, I think we can say that 35 and 5, we can divide them both by 5. So we're going to end up with a 7 and a 1. And then if we look at 4 and 26, we can divide those both by 2. So this will be 13 and 2. So 7 times 13 on top is going to be 91. And then 2 times 1 is going to be 2. So if we go ahead and divide 91 by 2 to turn this into a mixed number, 2 goes into 91 45 times with 1 left over. So it's going to be 45 1/2 here. So that's going to be our product. For number 4, we have another mixed number multiplied by a whole number. So 9 times 8 is going to be 72 plus the 3 here. That's going to be 75. So we're looking at 75 over 8. We're going to go ahead and multiply that by 12. But 12 as a fraction is going to be, we can just write that as 12 over 1, right? Now, let's see. As one fraction, we're going to say this is 75 multiplied by 12. And on the bottom, we have 8 times 1. Which one of these has a common factor, hopefully? Well, 8 and 12 can both divide by 4. So this would be 3 and this would be 2. Okay, so the numbers are a little smaller, which is nice. And then 75 times 3, 75 plus 75 is 150, plus another 75 is 225. So this would be 225 over 2. And if you go ahead and divide 225 by 2, we should get, what, 112? If you double that, that's 224, so there's 1 left over, or it's 1 away from 225. So I think this is going to be 112 1/2. This will be the product here. All right, now that we practiced multiplying a few times and finding some products, let's go ahead and practice finding some quotients or the answer to some division problems. So just like multiplying fractions, we like having a numerator and denominator. So let's go ahead and rewrite this 6 as 6 over 1. And we're going to divide this and see how many times 1/3 fits into 6, right? Now keep in mind, we can turn all division problems into multiplication problems if we multiply the first fraction by the reciprocal of the second fraction. So we're going to keep, change, flip here, or also known as keep the 6 as 6 over 1, change division to multiplication, then flip the 1/3 to 3 over 1, or write the reciprocal. And then 6 times 3 here, that's just going to be 18. And then 1 times 1 is going to be 1. So this simplifies to just saying 18 is the answer as a whole number. So you can fit 1/3 into 6, 18 times. For number 6, we have a whole number and we have a mixed number here. So 18, we can say, just like before, is 18 over 1 divided by, now turning this mixed number to an improper fraction, 4 times 2 is 8 plus 1 is going to be 9. So we're looking at 9/4. And let's see, this is a nice division problem that we can turn into a multiplication problem, right? So we're going to go ahead and keep, change, flip. So it's going to be 18 over 1 multiplied by this 4 over 9. Now, you could write it as one fraction, but I'm going to leave them separate for now in case that's helpful. And we can go ahead and cross cancel here. So 9 and 18 both can divide by 9. That's their GCF. So you're going to be left with 1 and 2 here. And I think that's it. So 2 times 4 is going to be 8 on top, and 1 times 1 is going to be 1 on bottom. So this is actually also going to be a whole number answer of 8. So 2 1/4 will fit into 18 8 different times. For number 7, we have 12 and 1/4 divided by 2 1/3. So let's go ahead and turn these both into improper fractions first, right? Just like we did in the past couple examples. So 12 times 4 is going to be 48, plus the 1 is going to be 49. So we're looking at 49 over 4 divided by, and 2 times 3 is 6 plus 1, that's going to be 7. So it's going to be 7 over 3. All right, perfect. Now let's go ahead and just turn this into a multiplication problem. So rewriting this as a multiplication problem, this would be 49 over 4 multiplied by 3 over 7. All right, so let's go ahead and see if we can cross cancel. The 3 and 4 have nothing in common, but the 7 and 49 can both divide by 7. We're going to get 1 and 7 here. Now, I think that's it. 7 times 3 is going to be 21 for the numerator, and 4 times 1 is going to be 4 for the denominator. Now, 4 goes into 21 5 times with 1 left over, so we're looking at 5 and 1/4. So that would be our quotient here. So we now know that 2 1/3 fits inside of 12 1/4, 5 1/4 times. For number 8, let's go ahead and turn these mixed numbers into improper fractions first, right? So that way we can go ahead and divide. And so for the first fraction, 9 times 6 is going to be 54. 54 plus 1 is going to be 55. So we're looking at 55 over 6 here, divided by. And then for the second fraction, 12 times 7 is going to be 84. 84 plus 4 is going to be 88. So we're looking at 88 over 7. All right, now that we have a numerator and denominator, let's go ahead and rewrite this as a multiplication problem. Let's keep, change, and flip. And so if we do that, we're looking at 55 over 6, and we're going to multiply by the reciprocal of the second fraction, so 7 over 88. Let's see, can we do some cross canceling? I think for 55 and 88, we can divide them both by 11. So we're going to get 5 here and 8. I don't think we can cross cancel anymore. Nothing seems to have anything in common here. So 5 times 7 on top is going to be 35. And then 6 times 8 is going to be 48 for the denominator. So our quotient here is going to be 35 over 48, which hopefully makes sense. It's a proper fraction here because we can't fit the 12 and 4/7 a whole number of times into that 9 and 1/6 because it's larger than it. All right, let's take a look at numbers 9 through 12. This time we have a couple operations in here. So let's just go ahead and see that because they're all multiplication and division, we're going to solve one operation at a time and go from left to right. Or you can see that if it's all multiplication, you can also cross cancel between any of the fractions if you would like to. So for number 9, looks like we have a whole number here of 6. I'm going to rewrite that as 6 over 1. All right, and then the 2/3 is perfectly fine. We're going to go ahead and just leave that alone. And then we have this mixed number. So 2 times 5 is going to be 10. 10 plus the 2 on top is going to be 12. So I'm going to write times 12 over 5 here. Okay, so this is how we could rewrite this. Now you could do one step at a time, but because it's all multiplication, what I'm going to do is I'm going to cross cancel between any numerator and denominator that I want to. So feel free to do that as well, as long as it's something on top and something on bottom. So looks like the only thing I really see here actually is the 3 and 6 maybe, or you could do 3 and 12 if you want to. 3 and 6 can both divide by 3, so it'll be a 1 and a 2. And I think that's it. So on top here, 2 times 2 is 4. 4 times 12 is going to be 48. And then on the bottom, we have 1 times 1 times 5, which is 5. And I think these are relatively prime here, right? So 5 goes into 48 9 times. 9 times 5 is 45 with 3 left over. So we're looking at a end answer here of 9 3/5. For number 10, let's go ahead and see we have a couple division problems to deal with here. So let's go ahead and rewrite this, right? So we have this 7/8 here. Let's go ahead and keep that the same. Let's see, we got to divide by this 4 2/3, so we got to turn that into an improper fraction. So 4 times 3 is 12 plus the 2, that's going to be 14, so 14 over 3. And then we have to divide this by this proper fraction of 7/12. Okay, so let's see here. We could do this one step at a time and just divide the first two fractions, but I'm just going to go ahead and rewrite this whole thing as a multiplication problem. So we're going to keep this one. I'm going to multiply by the reciprocal of the second fraction, so it's times 3/14. But then a little later on, we're going to have to also multiply by the reciprocal of 7 over 12. So we're just going to write 12 over 7. So again, feel free to break this up into a couple smaller steps, but I'm just going to rewrite this whole thing as one multiplication problem here. All right, now let's see if we can cross cancel a little bit. Oh, these 7s are really nice, right? So 7 and 7, those both become 1s. That saves us some work a little later. And let's see, this 8 and 12, we can divide them both by 4. That becomes a 2, and that would become a 3 over here. And I think that's going to be it. So if we go ahead and multiply the numerators together, 1 times 3 times 3 is going to be 9. And for the denominators, 2 times 14 times 1 is going to be 28. So we have a final answer here of 9/28. For number 11, let's go ahead and rewrite these mixed numbers here. So let's go ahead and take this 4 multiplied by 5, then add 1. 1 times 7 plus 3, then 2 times 4 plus 1. So let's turn these all into improper fractions first. For the first one, we should get 21 over 5 multiplied by this, I think it's going to be 10 over 7. And then we're going to divide this by 9 over 4. Okay, so that's just this whole thing written using improper fractions here. So let's go ahead and keep the 21 and 5 and multiply by 10 over 7. Those are fine. But for the dividing here at the end, let's go ahead and just turn this into a multiplication problem and multiply it by 4 over 9. So this way we can just kind of go ahead and cross cancel, right? So right away, I think 7 and 21, I can divide them both by 7 to get 1 and 3. And then let's see here, for the 5 and 10, I'd like to divide them both by 5 to make this 1 and 2. Now also I see this 3 and 9 here, they can both divide by 3, so this would become 1 and this would become 3 down here. And I think that's going to be it. So on the top here, we have 1 times 2 times 4, which is going to be 8. And on the bottom, we have 1 times 1 times 3, which is 3. So 8 over 3 is the same thing as 2 and 2/3. So that would be the answer to this problem here. For number 12, let's go ahead and rewrite these mixed numbers and whole numbers into improper fractions. So 5 times 6 plus 5, that's going to be what, 35 over 6. And then we're going to divide this by 14, but 14 is just going to be 14 over 1. And then for this last mixed number, 2 times 7 is 14, plus the 4 is going to be 18. So we're looking at 18 over 7. So let's go ahead and rewrite this so everything is multiplication. So I'm going to keep this 35 over 6, multiply by the reciprocal of 14 over 1, which is 1 over 14, and then multiply this by this 18 over 7. All right, now that everything's multiplication, we can look to cross cancel a bit here. Let's see, for the 14 and 35, I'm going to divide these both by 7. I'm going to end up with 2, and let's go with 5 up top here. And then let's see, 6 and 18, we can divide these both by 6. So that's going to be 1 and that's 3. And I think there's nothing else here. So 5 times 3 times 1 is going to be 15 on top. And then 1 times 2 times 7 is going to be 14 on bottom. So I think here as a mixed number, we can just say this is 1 and 1/14, which would be our final answer. All right, cool. Now that we went ahead and did some multi-step problems with multiplying and dividing, let's take a look at multiplying or dividing some monomial or rational expressions together. All right, first things first, I think we should just go ahead and look at one of these monomial expressions at a time. All right, so simplifying this first expression here, let's see what they have in common. Well, the 8 and 9 have nothing in common, so those are just going to stay in the top and the bottom. The numerator has one more a than the denominator, so there's going to be no more a's on bottom, but one more on top. And the bottom has 3 more b's than the numerator does, so we're going to be left with b cubed there. So the GCF of those two monomials for the top and bottom was going to be a b to the 4th power. Okay, so that's going to be a simplified version of that one. Now for the second expression here, let's see, the 15 and 16 have nothing in common either, so let's go ahead and just rewrite those ones. And then we can see here that the bottom has one more a than the top, so that one's going to keep the a on the bottom. And then there's no common b bases here, so the b squared is going to stay in the denominator of this expression, right? So the 15, we could actually just move it over if you would like to, but that's what we would be multiplying. Okay, now you can go ahead and cross cancel now, especially with the coefficients. I think I'm going to break it up into coefficients first and just deal with the variables second. And so for the coefficients here, 8 and 16 can both divide by 8, so it's going to be 1 and 2. And then let's see, the 9 and 15 can both divide by 3, so we're going to be left with 3 and 5. I think that's it for the coefficients here, right? So what I'm going to do is just multiply the numerators. Again, I'm going to deal with the variables in just a moment. So 1 times 5 is going to be 5, and then we have this a on top. And then on the bottom, we have 3 times 2, which is going to be 6. And then we have 1a there, and then we have b to the 3rd power times b to the 2nd power, which is going to be b to the 5th power for multiplying 5 of those b's together. Now, just like we were cross-canceling earlier, we have this common factor of a and a on the numerator and denominator, so each of those a's can cancel out. So I think we're going to be looking here at 5 over 6b to the 5th power. So that would be our final expression. 5 in the top, and then 6b to the 5th power on the bottom. All right, let's take a look at number 14. Number 14, we have another similar type of problem. We're multiplying. So let's see if we can just simplify each of these monomial expressions on their own, or each of these fractional expressions or rational expressions. All right, so for this first expression here, we can see 18 and 35, they have nothing in common here. So let's go ahead and keep the 18 and keep the 35. Now in terms of the c's, the top has 2 more c's than the bottom, so we're going to be having the c squared on top. And then we also have 1 more d on top than on bottom, so the d is going to stay there, right? So the 35 I'm just going to move over, and that's going to be the more simplified version of that first expression. Now, as for the second expression here, we have this 42 and 27. 42 and 27 can both divide by 3, so I'm going to put 14 and 9 as those new whole numbers or coefficients in front of the variables, just to make the numbers a little smaller. And then for the c's, it looks like the bottom has 3 more c's than the top, so we would cancel out 5 on top and 5 on bottom. And then for the d's, it looks like the denominator has 4 more than the top, so it's going to be d to the 4th power. All right, so let's go ahead and just move this 14 into the middle here. I think everything else canceled out. All right, so everything in terms of their own fractions are relatively prime, but we can cancel out some things diagonally or cross cancel before we multiply here. So let's just take care of the coefficients right now. So 9 and 18 can both divide by 9, so that's going to be 1 and 2. And then for the 35 and 14, those can both divide by 7. That's going to be 2 and 5. All right, so again, we're going to do the coefficients right now, which is all the whole numbers in front of the variables, and then I think we'll just deal with the variables second, just to keep it a little bit more clear. So in terms of the whole numbers, 2 times 2 is going to be 4. Looks like we have c squared and d left in the numerator. For the denominator, 5 times 1 is going to be 5, and then it looks like we have c to the 3rd power and d to the 4th power. Okay, so now that we took care of the numbers in front, those coefficients, we can just look at the variables. So let's see here. For the c's, actually, let me write the coefficients first here. So the 4 and 5 are going to stay, right? And then the c's, looks like the bottom has 1 more c than the top, and the bottom has 3 more d's than the numerator. So I think we're going to be looking at 4 over this 5cd to the 3rd power. So I think that's going to be our answer. It's going to be 4 on top, and it's going to be 5 multiplied by c multiplied by d to the 3rd power. All right, for number 15, it looks like we are going to be dividing some of these expressions together, so make sure we do turn these into multiplication problems as well. All right, first let's just go ahead and simplify these expressions though. 10 and 21 don't look like they have anything in common, so I'm not going to do anything with those. I think I'm just going to keep the 10 on top and the 21 on bottom. I think all the variables on the bottom are going to cancel out just because all the exponents on top for e and f are greater. So it looks like there's one more e on top and there's 5 more f's on top. So I think this would be the most simplified expression here. Okay, now let's go ahead and divide this by the second fraction here. I'm not going to go ahead and flip it yet. But for the second fraction here, the 15 and the 28, nothing can be done with those because their GCF is going to be 1 here. But let's see here. In terms of the e's, it looks like the bottom is going to have 3 more e's than the top. So I'm going to put e to the third power. And the top has 4 more f's than the denominator. So we have f to the fourth power. All right, so this would be the more simplified way of writing these rational expressions. But then if we want to turn this into a multiplication problem, if we want to go ahead and try cross-canceling, we can go ahead and do that. So we're going to keep this 10e f to the fifth power and keep that over 21. But let's multiply by the reciprocal of the second expression here. So it's going to be 28e to the third power over this 15f to the fourth power. Okay, so now it's a multiplication problem. We can go ahead and start cross-canceling. So 10 and 15, you can divide them both by 5. That'll be 2 and 3. And then for our 21 and 28 here, you can divide those both by 7. So that would be 3 and that would be 4 here. Okay, so while it's not fully simplified here, I'm going to go ahead and write these a little bit more cleaned up, and then we'll deal with the variables in just a moment. So 2 times 4 is going to be 8 on top, and 3 times 3 is going to be 9 on bottom. Then on top we have 1 e multiplied by 3 more e's, so that's a total of 4 e's being multiplied together. And then we just have this f to the fifth power that we don't really need to do anything yet with. And on the bottom we just have f to the fourth power. Okay, so we're almost there. What does the numerator and denominator have in common? Well, I think 8 and 9 have nothing in common, but the f's, it looks like, well, actually the e's all right next. E to the fourth power, there's nothing in common. But it looks like the f's, there's 4 f's on bottom and 5 f's on top. So it looks like there's one more f on top than bottom. So 4 of them are going to cancel out. So this 9 is going to be the only thing left in the denominator. So I think our final answer here is going to be 8e to the fourth power multiplied by f all over 9. For number 16, we have another division problem. So let's go ahead and treat it kind of similarly to how we did in 15. All right, so for this first expression here, the 36 and 25 have nothing in common. So I'm going to leave those alone. The top has 1 more g than the bottom. So we're going to be left with 1 g on top. And it looks like the top has 4 more h's than the bottom. So we're going to write h to the fourth power on top because 3 of the h's are canceled out. 25 is going to just slide to the middle here because everything else canceled out. Now what about the second fraction or second rational expression? For here, the 48 and 35 have nothing in common, so let's go ahead and I'm going to put this 48 in the middle because I see all the variables are going to cancel out. The 35 is going to stay over here. There are 3 more g's on the bottom than there are on the top, and there are 4 more h's on the bottom than there are on the top. So this would be the more simplified way of writing each of these fractions. And let's go ahead and turn this into a multiplication expression instead of a division one. So if we go ahead and do that, let's keep this 36 gh to the fourth power, keep that over this 25, and multiplying by the reciprocal of the second fraction here, it's going to be 35 g to the third power h to the fourth power all over 48. All right, so a lot of big numbers here, but I think we can do some good cross-canceling. So 35 and 25 can both divide by 5, so we're going to be left with 5 and 7. And then when it comes to this 36 and 48, they're both divisible by 12, so this would be 3 and this would be 4. All right, I don't think there's any more cross-canceling we can do here. So let's see here. In terms of the coefficients, 3 times 7 is going to be 21. And let's see how many g's are there on top. Well, there's 1 g multiplied by 3 more g's, so that's g to the fourth power. And then there's h to the fourth power times h to the fourth power. That's a total of 8 h's being multiplied together. And let's see, this is all on top of 5 times 4 is going to be 20. And I think there's no variables on the bottom at all, right? So I might as well just move this 20 right into the middle here. So I think for our final answer, we're going to have 21 g to the fourth power, h to the eighth power, and this is going to be all on top of 20. This right here would be our most simplified answer to this expression. All right, let's check out a couple more problems. This time we're going to be looking at some geometry. So for number 17, we have a rectangle that has a length of 6 3/4 meters and an area of 25 1/5 square meters. Write and solve an equation to determine the width of this rectangle. Okay, so for rectangles, and we're dealing with area, area is equal to length multiplied by the width. Okay, now what do we know here? We know the area. We're told that the area here is 25 1/5. And we're also told that the length here is going to be 6 3/4. So I'm just writing down those values that we were given. And so if we're trying to find the width here though, if we know that length times width is area, we could also rearrange this equation and say the width here is going to be the area divided by the length. All right, so I think it's good to kind of know how to rearrange those values there, or those variables. Now let's see, if we're going to find the width here, that's going to be the area, which is 25 1/5. And we're going to divide that by the length here of 6 3/4. So let's see, if we're going to turn this into a problem that we can actually work with, let's go ahead and turn these into improper fractions. So 25 times 5 is 125 plus 1. That's going to be 126 over 5 divided by, and as an improper fraction, 6 times 4 is 24 plus 3. That's going to be 27. So we're looking at 27 over 4. All right, so we have a division problem, but we can rewrite it as a multiplication problem. So we can keep this 126 over 5 and multiply this by what? By 4 over 27. Now the 4 and 5 are relatively prime, but 126 and 7, I think we can divide those both by 9. If we divide 27 by 9, we're going to get 3. And if we divide 126 by 9, I think that's going to be 14. 14 times 9 is 126. I think that's it though in terms of simplifying. So the width here should be 14 times 4, which I believe is 56. And then on the bottom we have 3 times 5, which is 15. Now as a mixed number, 15 is going to fit into 56 3 times. 3 times 15 is 45. I think we have 11 left over, so we're looking at 11/15 here. All right, so putting this all together, we can go ahead and say that the width of this rectangle must be 3 11/15 meters. Now, if you want to go ahead and check it, feel free to take this 3 11/15, multiply it by the 6 3/4, and just double check that it does equal this 25 1/5. And if it does, then you know that this is also working out well as well. For number 18, we have a triangle here instead. For the triangle, we have a base of 9 4/5 yards, an area of 3 11 square yards. We're going to go ahead and write an equation to find the height of this triangle. All right, so if we're dealing with the area of a triangle, what's that formula? So area of a triangle, we can say, is going to be, one version of it at least is 1/2 times base times height. But you can also do base times height divided by 2. So what do we know here? We know the area here is going to be 3 11/15, right? And we know the base as well. So the base here is 9 4/5. What we don't know is the height here. So if we're going to try to find the height, if we know that area is 1/2 base times height, we can also rearrange this formula and say the height here is just going to be equal to 2 multiplied by the area, then divided by the base. You go ahead and just move over that 1/2 to the other side and the base to the other side, or you can find this formula just for finding and isolating to find out the height here. All right, so let's go ahead and see if we can find the height. The height here is going to be 2 multiplied by what? The area. The area is 3 11/15, and then we have to go ahead and divide that by 9 4/5. Okay. So this is going to be the expression that we're going to go ahead and solve on the right side, but the answer to that right side is going to be what the height is of this triangle. All right, so let's see the height here. How do you write 2 as a fraction? That's just 2 over 1. For these as improper fractions, 3 times 15 is 45. 45 plus 11 is going to be what? 56. I think it's going to be 56 over 15. And then we have to divide this by this as an improper fraction. 9 times 5, 45. 45 plus 4 is going to be 49. So we're looking at 49 over 5. All right. I think we can go ahead and just rewrite this as all of this as a multiplication problem. So we have 2 over 1 multiplied by 56 over 15, and then multiply this by 5 over 49. If you go ahead and rewrite this whole thing as a multiplication problem. And looking for cross-canceling here, 5 and 15 can both divide by 5, so that's going to be 1 and 3. And then if we go ahead and look at 56 and 49, you can divide those both by 7, and that would be 7 here, and this would be 8. And I think in terms of simplifying, we're just about done here. So let's see. On top here, we have 2 times 8, which is 16, times 1 is still 16. And on the bottom here, 1 times 3 times 7 is going to be 21. And so putting this all together, we can say that the height of this triangle is going to be 16 over 21 yards tall, which is going to be a little less than 1 yard, right? And hopefully that makes sense. If you wanted to go ahead and check this, of course, you can go ahead and take the base, which is 9 and 4/5. You can do base times height. If you go ahead and multiply 9 and 4/5 by the 16 over 21, and then take half of that, we should end up with this area here of 3 and 11/15. So if you want to go ahead and check that just for some practice, feel free to go ahead and do so. All right, so there you have 18 different practice problems dealing with finding products and quotients of fractions or rational numbers, as well as applying some of our understanding of monomial expressions as well, and try to multiply and dividing some of those as well. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.